for this video, let's identify the translation of our given line here, L, which is described as 3x minus 4y equals 12 by a vector of 3 and 2. You can see that I have already placed here the graph so to save us some time. And understand that we use here the intercepts to plot this one. If you are not yet convinced with this, you can of course graph this on your own. And I'm placing that here so that we could automatically proceed with the target, which is the translation. Take note that if we're going to translate a line by a certain vector, it works similar into translating a point by a vector. Since line is consists of at least 2 points, then it works the same way. Our line is somewhere maybe pushed. It may be pushed. When we talk about translation, it is being pushed into the direction, or maybe pushed into this direction, depending on what our vector is. Take note, our vector is actually at 3 and 2. When you consider that as a sole part of the graph, it's actually said right here, it is pushing towards our first quadrant. So basically, we could actually expect as well that for any point in this graph, it's somehow being pushed into this direction as well. We will be finding that out later if we have the same understanding with the vector itself. So this time, let's proceed to the translation. The translation is actually would use a certain formula. Take note that for this case, this one here, this function is expressed as in terms of x and y. Any point in that is x and y. But for our translation, we'll be looking for x prime and y primes. Okay, it's a point on our line. Now to do that, take note, for translating a point, let's say xy, okay, so translating a y using a vector with components v sub 1 and v sub 2. For our translated, we have this form, the translated components of your x using a vector is actually the sum of the components of your point x and then the vector. It would be x sub 1 plus your v sub 1, and you have here it's actually your second component x sub 2 plus v sub 2. But since we denote all points in our given line as x and y, we can change it in this manner. It's just x, this is just y. So that's x and y. So that's for every point. Okay, so say for example, just like your x-intercept being 4, 0, and then since we have here our vector at 3 and 2, we can identify already the translation of 4 is 0 by a vector of 3, 2 by adding them. Okay, the specific components. But since it works for all, let us also come up with a general form of our line. So in order for us to identify the graph, let's come up with an equation of a line similar to this. Let's label it as L prime with components of x prime and y prime. Okay, so take note that our L here is identified as 3x minus 4y is equal to 12. And our x is actually applicable here. Okay, so our x prime, okay, since this is also equivalent here to x prime and y prime, the translation that is equivalent, this is actually equal to x plus v sub 1, and our y prime is equal to our y plus v sub 2. Our v sub 1 and v sub 2 is connected to our vector here, so our v sub 1 is 3, our v sub 2 is 2. So you can see here that our x prime is just x plus 3, and our y prime is y plus 2. As mentioned, every component of our x and our point in the given line will be pushed 3 units, and for our y, pushed y units. Now, since we would like to come up with an equation similar to that, let us try to solve x here to be substituted in our given equation so that it would be in terms of x prime, and for our y in terms of y prime. That would mean for this here, you can have x is equal to your x prime minus 3. And then for our y, in this case, that's actually y prime minus 2. So when we use this for representations for our x and y, we could come up with our equation, which is actually L prime. So let us have it here. What will happen is instead of 3x minus 4y equals 12, using these components, you have 3 times x prime minus 3 minus 4, and you have here y prime minus 2 is equal to 12. The result of this would correspond to your equation of a line L prime. Let's simply continue. You will have here 3 x prime minus 9 minus 4 y prime plus, take it off the signs, 8 is equal to 12. Okay, that would mean you can have here 3 x prime minus 4 y prime is minus 1 equal to 12. In short, you have here your L prime, okay, is the equation 3x prime minus 4y prime equal to 13. Okay, this would be the line, the translated line, okay, for our given line using the vector 3 and 2. To look into that closely, let's try to come up with the x-intercept of this, or x prime intercepts if you would like to. So let's start here. Let's let y prime be equal to 0. So you will have here 3x prime is equal to 13. Or if you would like to, let's do it step by step. Minus 0 is equal to 13. 3x prime is 13. So x prime is 13 thirds. Okay? So 13 thirds. For our, this means that our point here is at 13 thirds and 0. For the second one, let x prime be 0. So you have here 0 minus 4y prime is equal to 13. So minus 4y prime is 13. So you will have your y prime is negative 13 fourths, or 0 and negative 13 fourths. This would be the 2 points needed in order for us to graph this. And as you can see, it's actually parallel. It has the same coefficients as the given, so it must be parallel. So assuming that we can plot it carefully, okay, 13 thirds is actually 4 and 1/3. So 4 and 1/3 is, it's close to 4, but it's somewhere here. Okay, and as for 13 fourths is actually 3 and 1/4, right? Negative 3 and 1/4. So negative 3 and 1/4 is still somewhere here. So if we're going to connect that, so it's very close, okay, very close to our graph, but it would be like this. Let me graph it first. Somewhere here, very, very close. Okay, so it's very close, and as mentioned, it was being pushed into this direction following our vector. So we can see that they are actually parallel, and this is the translated line. That's our L prime. Okay, given as 3x prime, or let me use the other side for this. Okay, let us have it here. This, that's our L prime, identified as 3x prime minus 4y prime is equal to 13, right? Is equal to 13. This is the translated line of the given. Okay, so this is how we do it, especially with the graph already presented earlier. Thank you very much for watching.